Yun na lang ako pag biglang nawala yung share screen ko, ha. Okay, good morning, everyone. So today we'll continue our discussion about relations. Specifically, we'll be talking about one special kind of relation. They're called equivalence relations. And there are just some three properties that should be satisfied by a given relation para ito ay maging isang equivalence relation. Tapos papakita natin ano yung consequence, so ano yung maging magandang property ng pagiging isang equivalence relation. All right. But before that, I just realized that November 30th is a regular holiday. So that means we won't be seeing each other live on Tuesday. Okay. Tapos kasama siya dun sa bilang ko ng araw para sa problem set number 2, which will come live on Canvas on the 29th. So dahil holiday ang 30th, okay lang ba kung i-move ko yung deadline ng December 2? Para you can spend the holiday with your families, or you can take a break from your ACADS para wag niyo siyang isipin. So I'll give you a free pass on the 30th, okay? So December 2 na yung deadline ng problem set number 2, all right? And then I made some adjustments on the deadlines of worksheets sa Canvas. Ginawa ko lang siya kahapon kasi baka nagpapanik kayo. Meron yata naka-due on November 29th. I forgot what number it is. But the worksheet due on the 29th was moved, I think, to December 3rd. So paki-check na lang yung deadlines kay Canvas. Okay, though I already saw a lot of submissions done. So yeah. And then what else? Yeah, I think that's it. So let's move forward and see kung ano ba itong mga equivalence relations. But before that, let me introduce one other relation. Last time, I think we finished talking about, or we ended the class last time talking about congruence relation. Yeah, the congruence relation modulo N. So ngayon, meron pa akong isang relation na ipapakilala sa inyo, pero mas ano to, mas simple. This is called the identity relation. So as the name implies, the identity relation is a relation from a set A to itself. So basically, it is a relation in a set A, wherein every member is assigned to itself and only to itself. All right. So kung meron kang yung identity relation, usually denoted by little I sub A. So yung subscript denotes what the set, kung anong set kung saang set nakadefine yung relation. So I sub A is a relation in A, the identity relation in A, and it is the set of all ordered pairs whose first and second components are the same, and that will happen for all element of A. So ibig sabihin, lahat ng A ay related sa sarili, lahat ng elements ni A ay related sa sarili niya, at dun lamang sila related. So wala nang ibang laman yung relation, kundi yung mga ordered pairs of the form X, X. So for instance, if we have four elements in the set capital A, then the identity relation in capital A will contain four members. So halimbawa si A ay set of all letters in the word love, all right? So apat lang lamang yung laman ng identity relation. L related to L, O related to O, E related to E, and V related to V. Okay, so yun lang yung mga elements niya. So kaya identity, kasi ang related lang sa isang element ng set ay yung sarili niya. Okay? Now, let's see what equivalence relations are. So ready na tayo dito. So, okay, so here we have the definition. We say that a relation row in a set A is probably I'll add something to the definition. Maybe else hold on. Okay, covered din naman siya ng property 1. So hindi ko na idadagdag. So ang isang relation para maging isang hold on. Di pa pala niya okay. Di pa pala niya define kung ano yung equivalence relation. Pero anyway, in definition 18, define niya muna yung tatlong properties na kailangan para maging isang equivalence relation. So ito yung pagiging reflexive, symmetric, at saka transitive. Okay? But I think we have seen this before in the context of equality of sets, all right? So if you remember 2 weeks back or last week, I don't remember exactly, pero napakita natin ng ang equality of sets, meron siyang tatlong property na tinataglay. Yun yung reflexive, symmetric, at saka transitive. So we will just study those three properties in the context of much more general relations. And let's see exactly how these properties are defined. So we say that a relation in a set A, so ang pinag-usapan lang natin dito yung mga subsets ni A cross A. So una, reflexive siya if and only if X is row related to X for all X in A. So para maging reflexive siya, dapat lahat ng element ni A ay related sa sarili niya. Okay? So I think that's pretty straightforward. Next is symmetry. So a relation in A is symmetric if and only if X related to Y implies Y is related to X for all X and Y in the set A. So, ibig sabihin, kapag ka nakakita ka ng element na X na related kay Y, kung symmetric yung relation, dapat mag-follow na pwede mong pagpalitin yung order ng components ng ordered pair. So, kung si X, Y ay na kay row, dapat si Y, X ay na kay row din. Okay? So, parang pwede nyo itong isipin as a mutual relation. So, kapag ka si X ay related kay Y, dapat si Y related din kay X. Kasi kahit sa set theory, meron ding mga one-sided relation. Ow. So, pero kasi pagka si X ay related kay Y, hindi nagfa-follow na si Y ay related kay X. Pero if your relation is symmetric, then automatic na kapag ka si X ay related kay Y, si Y ay dapat related kay X. Alright? So parang nagkakaroon ng mutual relation between the two elements of the set X, the set A. And then the third one is transitive. And as the name implies, parang sequence to, parang tipong hypothetical syllogism. Kapag ka daw si X ay row related kay Y, tapos si Y ay related kay Z, dapat magpa-follow na si X ay related kay Z. So parang change siya. So si X ay related kay Y, tapos si Y ay related din kay Z, para maging transitive, dapat si X ay related din kay Z. So in proving something is transitive, you need to assume that X and Y are related, or X is related to Y, and Y is related to Z. And your goal is to show that X is related to Z. Okay? So that's the transitive property. So let's look at quick examples para makita natin yung tangible instances nitong tatlong properties na to. So let's consider the set A to be the set 1, 2, and 3. Okay? And let's have the relation R1. Okay. So relation R1 daw ay, tingnan natin kung siya ay reflexive. Para maging reflexive, dapat si 1 related kay 1, si 2 related kay 2, at saka si 3 related kay 3. Alright? So let's check. Is 1, 1 in the relation R1? Yes, it is. So we're good. How about 2? Oops, sorry. How about 2, 2, is 2 related to itself? Yes, it is. Oh, fine. But look at the third element. Third element is 3. Do we see a 3, 3 in the relation R1? We don't. So therefore, we say that R1 is not reflexive because there is at least one element, or actually in this case, there's exactly one element that is not related to itself. So may isa lang element na hindi maging related sa kanyang sarili, hindi na siya reflexive. Okay? Let's check symmetry. So si 1 ay related kay 2, so dapat pwede kong i-flip yung ordering. So 1 is related to 2, so for the relation to be symmetric, 2 must be related to 1. And true enough, we have 2 related to 1. Now we have 1, 1. Pag finlip natin yan, 1, 1 pa rin naman, so we don't have any problem with that. And then, oops, what's happening with my notability today? And we have 2, 2. So pag binaligtad mo, 2, 2 pa rin. So it is symmetric. Kasi kapag ka nakakita ka ng X, Y dun sa relation, automatic na si Y, X nandun din sa relation. Okay? So, yon. Kailangan nyo lang i-check sa symmetry. Pag binaligtad ko ba yung isang element ng relation, okay? I mean, pag sinabi kong binaligtad, in-interchange ko yung role ng first at saka second components, dapat nandun pa rin sa relation yung resulting ordered pair. Okay? And then, let's see transitive. Sa transitivity, dapat meron silang nasa-sandwich na element. So, kung si X ay related kay Y, si Y related kay Z, so sort of parang si Y ay sandwiched between X and Z. Kapag ka si Y ay sandwiched between X and Z, yung transitive property, sasabihin niya na si X ay dapat related kay Z. So, pwede niyong isipin na parang bridge o parang tulay si Y sa pagiging related ni X at saka ni Z. Alright? So let's see. I-check natin to for every pair. So for instance, umpisa natin dito sa dalawa na to. And they share a sandwich element. Nasa sandwich si 2. So dapat, dahil nasa sandwich si 2, it should serve as a bridge between the first component of the first set and the first component of the first ordered pair and the second component of the second ordered pair. So dahil nasa sandwich si 2, dapat magko-collapse si 2, so matitira lang 1 related to 1. And true enough, 1 is related to 1. Okay, so that's good. Tapos meron pa bang nasa sandwich? Ito pa. Si 1, 2 at saka si 2, 2. Meron nasa sandwich sa kanila. Nasa sandwich sa kanila si 2. Si 2 kasi second element dito. Si 2 ay first element dito. So, ibig sabihin, masa-sandwich siya. So, pag nag-collapse si 2, matitira lang ay 1, 2. Is 1, 2 in the relation? Yes, it is. So, it is, so far, may chance pa siya na maging transitive. Let's see kung meron pang ganong case. Ito, second and third. Alright? So, nasa-sandwich sa kanila yung 1. So, pag kinolapse natin yan, matitira ay 2, 1. And true enough, 2, 1 is still in the relation. What else? Meron pa ba? Meron pa. 1, 1 at saka si 1, 2. Masasandwich si 1 at saka si 1. Pwede ko kasi siyang tingnan na 1, 1 at saka 1, 2. Since I have 1, 1 and 1, 2 in the relation, nasasandwich si 1. So magko-collapse siya, matitira lang is si 1, 2. Can I see a 1, 2 in the relation? Yes, we have. So, ibig sabihin, may chance na maging transitive pa siya. Kaya lang medyo matagal tong transitivity kasi kailangan nating i-check lahat ng possibilities. Meron pa ba ako na-miss na may nasa sandwich? I think meron pang isa. Si 2-2 at saka si 2-1. There's a sandwich si 2, alright? So pag nag-collapse si 2, matitira si 2-1 and 2-1 is in the relation. And would you agree that I have exhausted all such pairings na may nasa sandwich na element? I think so. So, and if that's the case, we can conclude that it is transitive, all right? Kasi sa lahat ng posibleng pairing na merong nasa sandwich na element, so yung resulting ordered pair ay nandun pa rin sa relation. Okay? Now, okay. Let's see example B. So example B, see R2. What can you say about R sub 2, the relation R sub 2? Is there something special about it? Okay, the relation R sub 2, yes, Daniel.
Identity relation po.
Okay, great. Thank you. That's right. R2 is the identity relation, and it being so, it is automatically reflexive, right? Kasi yun yung pinaka-definition ng pagiging identity relation. 1 is related to itself, 2 is related to itself, 3 is related to itself. And that happens for all elements of A. So that's fine. It's reflexive. Then, is it symmetric? Of course, pag finlip ko yung bawat element of the form x, x, ang makukuha ko lang uli ay x, x. So, obviously, that will still be in the relation. So, we say that R2 is symmetric. Is it transitive? Meron bang nasa sandwich? Wala, no? Kasi si 1, 1, wala nang ibang element na related kay wala nang ibang element na may 1 as first component. So, ang posible lang ay yung sarili niya, 1 and 1 and 1 and 1. Alright? Pag kinulaps ko yung gitna, matitira 1, 1 din, and 1, 1 is part of the identity relation. Okay? And nothing else. Ang may nasa sandwich na lang ay si 2, 2 at saka si 2, 2, tapos si 3, 3 at saka si 3, 3. Walang nasa sandwich si 1, 1 at saka si 1, 2 kasi magkaiba yung first and second components nila respectively. Okay? So automatically by default, this is transitive. So the relation R2 satisfies all three properties that we have defined. So tandaan nyo na, may dalawang klase ng relation tayo nakikita na nasa-satisfy yung tatlong properties. Yung equality of sets from last time and the identity relation. At least for the set A, but it is easy to extrapolate the pattern and you can conclude that any identity relation is reflexive, symmetric, and transitive. Okay? Now, sabi dito, example C, this is reflexive because 1, 1 is in R3, 2, 2, and 3, 3 are also in R3. It is transitive, okay? Just double check that it is, but it is not symmetric. Why do you say it is not symmetric? Or why did the vortex say it is not symmetric? Yes, Gad.
Because sir, yung 1 to po is an element of the relation po, pero yung 2, 1 hindi po.
Okay, perfect. Thank you. Thank you, Gad. Esther and Anne are also correct. Because if you look at R3, meron tayong 1, 2, pero pag binaligtad ko siya, magiging 2, 1, and 2, 1 is absent from R3. Okay? So that means R3 is not symmetric. Okay? All right, so you can work out exercise 20. Just let me know next time if you will have any problem with it. Now, okay, let's see. Medyo uh, medyo ayoko nung ayoko or medyo hate ko yung pag-check ng tatlong properties na to for enumerated relations. Kasi lalo na yung transitivity, medyo tedious. Marami kang kailangang i-check. Alright? So usually mas madaling ipakita ng isang relation defined by a mathematical formula satisfies all those three properties. Okay? Now, actually dito, hindi pa pala natin sure in example 21, pinapacheck sa atin kung ang relation defined by this symbol, how should we read this? Perhaps let's just read this as congruent. So let's say that A is congruent to B if and only if A times B equals 0. Okay, so that's our relation. That's the congruence relation in R. Two numbers A and B, or two real numbers A and B, will be related via congruence to each other if A times B is equal to 0. And let's now determine if the relation is reflexive, symmetric, and transitive. Now to check, so sulat ko lang siya. If and only if A times B equals 0. If we are checking reflexivity, okay, kailangan ang isang real number ay laging related sa sarili niya. However, 1 times 1 is not equal to 0, so A is not related via congruence to itself, right? So nakakita tayo ng at least isang real number na hindi related sa sarili niya. So we say that this relation is not reflexive. Okay. But is it symmetric though? Anyone who would like to volunteer kung siya ay symmetric o hindi? Kapag ka ba si A ay congruent kay B, si B ba ay magiging congruent kay A? Yes, Alisa?
Yes po, sir.
Bakit mo nasabi?
Kasi po, if AB is equals to 0, we know that AB is also equals to BA.
And that will still be 0. Perfect. Thank you, Alisa. So you can probably write it this way. So you suppose, sa pagpo-prove kasi ng symmetry, dapat mag-assume ka ng isang element ng relation, A comma B, a generic element, and you want to show that B is related to A, all right? So start ka sa pag-assume na A is related to B. Then use the definition. This means that A times B is equal to 0. But Elisa is correct. If A times B is 0, by commutativity of multiplication, B times A is also 0. And B times A equals 0 means that B is related to A. So tingnan yung maigi, naging careful ako dito. Kahit alam ko na yung multiplication ay commutative, kailangan kong dumaan dun sa mga detalye at bumalik dun sa paano define strictly yung relation. Yung A related, being related to B means that A times B is equal to 0. The element on the left is the first factor, the element on the right is the second factor, and the product must be equal to 0. And that's what I followed here. The direct consequence of A being related to B is that A times B is equal to 0. And then saka ko palang masasabi na B times A is also equal to 0, appealing to the commutative property of multiplication. And then I will use again the definition of the relation. The first factor is the left element. The second factor is the second element, or is the right element. So therefore, I can conclude that B is related to A. And hence, this is true for any A and B because A and B were arbitrarily chosen. So we can say that the relation is symmetric. Okay. Now, how about transitivity? So let me work this example out. So sa transitivity naman, mag-assume tayo ng tatlong elements nung set. So let A, B, and C be in R. Okay? R kasi yung set kung saan natin define yung relation. And then we assume na si A ay related kay B and si B ay related kay C. Kasi ang constituents nung transitivity dapat ay yung mga ordered pairs na may nasa sandwich na element. All right? So I will start by assuming arbitrary elements of the set such that A is related to B and B is related to C. And here we want to show that A is related to C. Okay? Tapos ang gagamitin ko dito ay definition lamang. So by definition of the relation, I can say that A times B is 0 and B times C is equal to 0. Okay? Paano ko ngayon mapapalabas yung A times C equals 0? Anyone? Okay. Imisan? Sagot na kasi si Gad.
Ayun lang po, sir. Di po ako sure. We
Okay,
can
go ahead.
A times B equals B times C. Then divide both sides by B. Ay, hindi po pala. Mali po pala. Sorry po.
Sige,
Mali po
ulit.
pala. Realize ko po. Thank you po.
Mhm. Okay. Anyone else who wants to try? Actually, nag-iisip din ako ng madaling paraan. Yes, Victor?
Can we presume a B to be 0? Since A times B is 0 and B times C equals 0, one of them should be 0.
Pero couldn't it be A na equal kay
Or
0?
I mean A and C pala, sir, or something like that. One of them will be 0.
Yeah, I think I know where you're going to there. So isulat lang natin ng systematic yung argument ni Victor. And probably this is where Imisan is also going to. So i-organize ko lang. So alam natin na kapag si A times B ay equal kay 0, then either A equals 0 or B is equal to 0, right? Alam natin yan. Pag nag-multiply tayo ng dalawang real numbers na ang sagot ay equal kay 0, then at least one of the factors is equal to 0. So dahil ang A times B ay 0, isa sa kanila ay equal kay 0. The only problem is we don't know exactly who between them is equal to 0. So ang alam ko lang at most ay naka-OR yan. So si A yung 0 o si B yung 0. So what I can do here is to break this into two cases. So first case is maybe sabihin natin case 1, A equals 0, and case 2, the other possibility is that B is equal to 0. And I want to show that in either case, I will get A times C is equal to 0. All right. I see somebody raising their hand. Yes, Mitzi, you want to say something?
Sir, pwede po ba natin gawin na i-multiply po yung AB and BC, tas equate po sa 0 since both 0 sila, then divide by B squared both sides? Pwede po ba yun?
You can do that if you are sure that B is not equal to 0. Kasi kapag kasi B ay 0, yung B squared ay magiging 0. So the process you described will involve dividing both sides by 0, which is not allowed. Okay? So hatiin mo pa rin siya sa dalawang cases. First case is B is equal to 0, and second case is B is not equal to 0. You can do your suggestion if B is not 0. But what will happen if B is equal to 0? That's the question. All right? So kaya ayokong mag-involve ng division by both sides. Kasi baka mangyari na nagdi-divide pala ako kay 0, hindi ko namamalayan. All right? Does that make sense, Mitzi?
Yes po, sir. Thank you po.
Alright, yeah, yun yung ina-avoid. Yun yung iniisip ko kanina kasi baka pwede. Kasi para madali, hindi ko nahatiin sa dalawang cases pero magkakaroon siya ng butas. So, kaya I need to abandon that strategy. So now, hatiin ko siya sa dalawang cases. If A is equal to 0, then I already know that A times C is equal to 0. All right? So this will imply that A is related to C as desired. So kapag kasi A ay nag-0, okay, everything is fine. A is related to C. But again, we are not sure if A is equal to 0 kasi may isa pang possibility na si A ay non-zero pero si B yung non-zero. All right? So now I'll go to the second case and hope that this will also result to A being related to C. Now, what is the implication that B is equal to 0? Yes, Gad?
Sir, sorry, medyo nalipad yung utak ko. Ano po
Okay.
nangyari doon sa case 1 po? Sir, sorry, pa-explain mo.
Okay, no worries. Yeah, that's fine. Di ba, hinati ko siya sa dalawang cases. So, sa first case, halimbawa si A ay equal kay 0. Yun yung assumption dito. Dahil si A ay equal kay 0, sure na ako ng A times C ay 0. Alright? Kasi ito ay 0. 0 times C ay equal kay 0. So, dahil sure na ako sa case 1, kung saan si A ay equal kay 0, automatic yung AC magiging equal din kay 0. And by definition of the congruent relation dito, ang A ay magiging related kay C. Okay?
Okay po,
Is
sir.
that
Thank
good
you.
yan? All right. Now sa case 2, paano ko mapapakita na si A ay related kay C sa case 2? I only know that that B is equal to 0. Yun yung assumption sa case 2. Now if B is equal to 0, what can we say? Yes, Christian?
Hula lang po, sir.
Okay.
I think mahati din po ulit sa dalawa yung case. That is, kung B is equal to 0, it follows that C is 0 or C is not 0.
Okay. Yeah, that could work. So, meron pa dalawang sub-cases. Let's see. Yeah, I think I know what Christian is alluding to. Medyo agree ako doon. Yun yung pwede kong gawing susunod. Daniel, you have another idea?
Yes. Since by definition A times B is equal to 0, so we can, sorry. Sabog pala, sir. Sorry, hindi pala. Mali. Sorry.
Okay, no worries, yeah. Aha. Mhm. Natatempt akong silipin yung solution dun sa vortex. Baka mas maiksi dun sa iniisip nating solution. But I think Christian's suggestion might work. Let's see. Yes, Imisan?
What if po, sir, A times C is already equals to AC? Since B po yung 0, so... okay. Gets ko na mo pala yung point ni Christian. Okay pa. Gets ko na mo pala.
All right. Any other idea? I think maganda pag live, no? Sabay-sabay tayo nag-iisip. Yes, Mitzi.
Sir, tanong ko lang po, kasi po yung sa una po natin ginawa sa reflexivity, di ba po, nagbigay po tayo ng counterexample and then since na-prove na hindi totoo for one set of values, not reflexive na po siya. What if, makakapagbigay po kasi tayo ng counterexample for transitivity, so baka hindi po siya talaga transitive, tas nagpapakahirap po tayo.
Oh, that's a nice point, Mary. Yeah, tama. Hindi ko pala naisip. Hindi nga pala natin pinuprove na transitive siya, no? Ang tanong pala, is it transitive? And then I think Mary Mitzi is saying na merong counterexample. I didn't think of that. Oo nga, no? So, yes, Mitzi. Do you have a counterexample in mind? Sorry, medyo sabog pa rin ako ngayong umaga.
Sir, for example po, A is -1, B is 0, and then C is, say, 5 po. And then yung AC po natin will not be equal to 0, will be -5 po.
Okay, thank you, Mitzi. Yeah, that's a nice point. Sorry guys, medyo maaga pa kasi. So hindi ko nga naisip na hindi nga pala natin pinuprove na siya ay transitive. Ang tanong ay siya ba ay transitive o hindi. And this is a nice lesson. Whenever we are trying to determine whether whether a relation, or actually in any case, so mag-isip muna tayo, baka may counter example naman pala. All right? Kasi kung merong counter example, then we will not be able to show na na transitive siya talaga by a formal proof. At nakita nyo, tama, thank you, Mitzi, for that. -1 is related to 0 because obviously the product is equal to 0. 0, 5 is also in the relation because 0 times 5 is equal to 0. Nasa sandwich sa kanila si 0. At tingnan nyo, ito yung case kung saan tayo nahihirapan. Right? Nahirapan tayo kapag si B ay equal kay 0. Ito si A, ito si B, ito si B, tapos ito si C. Now, our doubts or our uncertainties for this proof is when B is equal to 0. And that is exactly what Mitzi pointed out here. Na kapag si B pala ay 0, posible na yung A at saka si C ay parehas non-zero. At pag sila ay parehas non-zero, never yung product nilang magiging equal kay 0. Okay, so by this example, we can say that it is not transitive because we have found two members nung relation na hindi nagkakasatisfy ng transitive property. All right? What I was thinking dun sa suggestion ni Christian kanina, mahati ito sa dalawang cases. Okay? Either C is not 0 or C is equal to 0. If C is equal to 0, then we're good. Okay? Pero kapag si C ay hindi 0, so kapag si C ay hindi 0, sure ako na si B ay 0, pero I already know that by assumption, okay? And I won't get anything about A. I'm still uncertain whether A will be 0 or not. So that means when C is not 0, then either A is 0 or A is non-zero at magkakaroon tayo ng problema kapag si A ay non-zero din. Okay, so that means that will really give rise to this to a counterexample of this form, as Mitzi pointed out, indeed showing that the relation is not transitive. Okay, so I hope that's clear, and it was a nice exercise talking about that. All right. Okay. So all right. So it is left at there is an exercise here, yung yung almost kabaligtaran naman nung relation congruent na tinify natin. In this exercise, we want to check if This relation is reflexive, symmetric, or transitive if the relation is defined this way. A times B is not equal to 0. So I guess you can try this out. So just let me know on, wala nga pala tayong classes sa Tuesday, pero just let me know if there would be some problems in here. May natutunan na naman kayo about illustration 21 na i-check muna for obvious counterexamples bago mag-proceed sa actual proof. Okay? Now, any questions so far dun sa tatlong properties, reflexive, transitive, and symmetric? So don't worry, we'll be proving more of them, or we'll be working with them in proofs more in the next couple of minutes, because we'll just give a name for those relations that satisfy all those three properties. So ang isang relation na reflexive, symmetric, at saka transitive ay tinatawag nating isang equivalence relation. Okay? Now, as promised, sinabi ko last time na babalikan natin yung congruence relation because they are nice examples of equivalence relations. But before going to example 24, I would just like to remind you na yung meron na tayong dalawang equivalence relations na nakilala. Una, equality of sets na prove natin last time na reflexive, symmetric, and transitive yon. Second ay yung identity relation, equivalence relation din siya. Tapos ano pa ba? Yung subset relation ay hindi equivalence relation kasi reflexive siya, transitive siya, pero hindi siya symmetric, right? Pag si A ay subset ni B, hindi nangangahulugan na si B ay subset ni A. All right? And actually, what the subset relation satisfies is anti-symmetry. Si A ay subset ni B, at kung mangyari na si B ay subset ni A, then we are sure that A is equal to B. So hindi siya pwedeng maging equivalence relation, or hindi siya equivalence relation. Okay? Now, another example is the congruence relation. In example 24, we are dealing with a specific example. Ito yung congruence modulo 4. Okay? So if you remember from last time, sabi natin, A is congruent to B modulo n if and only if n divides A minus B. So in this particular case, this is a congruence relation, but this time it's modulo 4, right? Because we are determining the relation rho by checking is x minus y divisible by 4? Or is that difference can be written as 4 times n? Okay? Now, let's see. There are some examples in here. 1 comma 5 is in row because 1 minus 5 is negative 4, and that can be written as 4 times negative 1. Okay. On the flip side, 5 comma 1 is also in row because 5 minus 1 is 4, and that's 4 times 1. However, 6 comma 3 is not in row because 6 minus 3 is equal to 3, which is not divisible by 4. All right? So I hope clear yung congruence relation, yung definition ng relation rho dito, siya ay modulo 4. Okay? So I hope that's fine because pupunta na tayo dun sa pagpo-prove na isa siyang equivalence relation. So let me know lang kung medyo malabo pa yung congruence relation kasi crucial siya. Yung understanding ng paano nag-work yung relation ay napaka-importante para mapakita na siya isang equivalence relation. Okay? So I hope walang nagtatanong. So I'll assume it's fine. So ngayon, sure tayo na isa siyang equivalence relation kasi ang pinapagawa sa example na to ay i-prove na siya ay isa talagang equivalence relation. Okay? Now we'll have our proof we'll have the proof in three sections. Una, pakita natin siya ay reflexive, transitive, at saka symmetric. All right? So medyo outline yung ipapakita kong proof. Idugsong nyo na lang yung mga phrases para maging isang kompletong paragraph siya. All right? Or you can read the proof on the work text. I will just be focusing here on the mathematical statements. All right? So now to show reflexivity, we will assume, pero sige na, sulat ko na siya ng buo. Medyo cringy kapag hindi talaga buong paragraph yung proof, right? So let X be an element of the set Z. Kasi yung relation natin ay isang relation row in Z. Okay? So, kukuha ko ng isang arbitrary element ng domain. Okay? So, dapat mapakita ko na si X ay related sa sarili niya. But we can say that X minus X. Okay, kasi kailangan nating i-check. Para si X maging row related kay Y, dapat yung X minus Y ay divisible by 4. So ngayon, kung i-check ko yung reflexivity, gusto ko makita is X related to itself. So I need to look at X minus X and see if this is divisible by 4. And nicely, X minus X is equal to 0, and 0 can be written as 4 times 0. 0 being an integer. So therefore, we see here that X minus X is divisible by 4. So we can say that X is row related to X for all X in Z, because X was arbitrarily chosen. So we can conclude here that row is reflexive. All right. Now, let's check symmetry. For symmetry, I will assume an ordered pair belonging to row. Okay, so ito yung template. Lagi kang magsimula. Assume X is related to Y. Now, our goal is to show that Y is related to X, right? So kung si X ay related kay Y, kailangan ipakita natin na si Y ay related kay X, all right? So since X is related to Y, then we know that X minus Y is equal to 4 times N for some integer N. Okay? Definition ng row relation. Okay? But if X minus Y is equal to 4N, I can multiply both sides by -1 and get Y minus X equals -4N. But by the associative and commutative property of multiplication, we can write it as 4 times -n, and still -n is an integer. All right? And now I can go back to the definition ng pagiging row related. So Y minus X was written as 4 times another integer. So that will imply that Y is row related to X. So here we have proven that if we start at X related to Y, then it will follow that Y is related to X. So that proves that row is symmetric. Okay. And then the last part, sorry, is transitivity, which could be a little tricky or more involved, but let's try. Okay. Sa transitivity naman, we will assume two members of the relation. This time dapat nasa sandwich yung isang element, all right? So what I mean is we will assume that X is related to Y and Y is related to Z. And we want to show that X is related to Z. Parang magsiserve na bridge si Y, magiging related na si X at saka si Z. Yun yung gusto nating ipakita. Now, usual thing is to, the usual next thing to do is to go back to the definition. Apply the definition of the relation row on your assumption. So we know that X minus Y can be written as 4 times N, and Y minus Z is equal to 4, say, M, for some integers M and N. All right? So, saan to nanggaling? In-apply ko lamang yung definition ng row dito. Kasi alam ko si X ay related kay Y, so this must be true. And I know that Y is related to Z, so this must also be true for some integers M and N. Now, balikan natin yung goal. Ang goal natin ay si x related kay z. So we must show that x minus z is divisible by 4. Para si x minus z ay maging divisible by 4, kailangan gamitin ko itong dalawang equations na alam ko. How can I get an x minus z out of these two equations? Any ideas? Yes, Mary Rose.
Sir, pwede pong hanapin yung value ng y for the first equation.
Uh-huh.
Magiging y is equal to x minus 4n po.
Okay, that will work. Yeah. So you can see that x ano nga yung gusto mo computein, y, no? So y is x minus 4n. Or yung kabila. Yeah, y is y minus 4n. Tapos ipa-plug in mo, saan mo ipa-plug in yung value? Let's see.
Sir, sa second equation po, papalitan yung value ng y magiging x minus 4n minus z is equal to 4m po.
Okay, I see. And then you will solve for x minus z from there. All right.
Yes.
So yeah, that will work, Mary Rose. So that's good. That to go. Yeah, pero ang iniisip ko ay may isa pang paraan. But valid yung approach mo, Mary Rose. The other way is to simply add both sides of the equation. Mukhang mas maiksi kasi ito, pero valid din naman yun sa'yo, Mary Rose. I-add ko lang yung both sides, yung corresponding sides ng dalawang equation. I mean, I'll add these two guys. I'll get x minus y by addition property of equality. Two sides being equal, I can add equal values to both sides. So x minus y plus y minus z is equal to 4n plus 4m. All right. So pinag-add ko lang yung dalawang sides ng equations. All right. And the nice thing about doing that ay magkakaroon ako ng shortcut dun sa gustong marating ni Mary Rose. So kasi makikita niyo yung left side, x minus y plus y minus z, again by the associative property of addition, I can group negative y and y first and get their sum. And luckily, negative y plus y is just 0. So I'll get x plus 0 minus z. So the left side will simplify to x minus z. Meanwhile, on the right-hand side, I can apply the distributive property of multiplication over addition. So in other words, pwede kong i-factor si 4, magiging n plus m. And since n and m are both integers, n plus m is also an integer. So since n plus m is obviously another integer, then we can say that x is related to z, because we have shown that x minus z is a multiple of 4. So therefore, rho is transitive. And in conjunction with the other two sections that we have written before, we can say that rho is an equivalence relation. Let's just abbreviate equivalence relation as a capital E dot R, okay? Para mas kakaunti yung isusulat natin. Okay? So any questions with that proof? Let me see. Okay, palitin ko. Doon din nyo na pala kailangan ito na naman sa work text yung actual proof, but it is always nice to write it on our own first. Yes, Mary Rose, may question ka ba? Or nakalimutan mo lang ibaba?
Sir, wala naman na po. Napindot lang po.
Sir, ako meron.
Okay. Yes, got it.
Pwede ko po screenshot, sir.
Okay. Yes. Zoom mo na lang later. Yes, Christian?
Sir,
Uh-huh.
it follows po ba na equivalence relation 0 kapag ang set is natural numbers, ay integers lang?
Yeah, good question. Yeah, equivalence relation siya for sure kapag ka ang set mo ay integer. So, isa siyang equivalence relation in Z. Pero kay R, hindi na siya magiging equivalence relation. Tama nga ba? Kasi, let's see. So, kung siya ay kay R naka-define, reflexive pa rin naman siya. Okay? Pero, tingnan natin. Kapag ka X, Y, alright, magiging symmetric pa rin siya. Pero magiging transitive ba siya? Ang problema kasi dito ay yung term na divisibility. Nag-work lang yung divisibility kapag ka, we're talking about integers. Pero you brought a nice question. Okay? So, tingnan natin. Kung si x ay real number, tapos halimbawa dito natin i-define yung relation. Alright? So, for sure, x is still related to itself kasi ang difference lang naman nila ay 0. Now, kung symmetric siya, symmetric ba siya? Yes, symmetric pa rin siya. Pero magiging transitive ba siya? Let's see. Dapat meron siyang hindi isang masatisfy. Let's see. Magiging transitive ba siya? Yeah, I think it will still be transitive. Kasi if you go back dun sa proof natin, wala akong ginamit dito na wala akong ginamit na property ni x at saka ni y being integers. Alright? Kasi, yeah, halimbawa, so obvious yung reflexive at saka symmetric, mag-work pa rin kahit real numbers si x at saka si y. Alright? Pero sa transitivity, I think mag-work pa rin siya. Kasi sa proof natin ng transitivity, wala naman akong ginamit ng pagiging integer o wala akong property ng pagiging integer ni x at saka ni y proof. Kasi kung si x ay related kay y, si x and y ay real numbers, so yung difference nila ay divisible by 4. Tapos kung si y minus z ay real numbers, tapos related sila, so dapat yung difference nila ay divisible din by 4. Mag-add lang ako both sides uli. Yung n plus m pa rin ay magiging integer. So yes, kahit palitan ko yung set ng R, equivalence relation pa rin etong congruence modulo 4. Okay? Yeah, it would be a nice extension. Okay, so though medyo nilimit lang yung example kasi usually we talk about divisibility only in the context of integers. Pero usually beyond that, hindi natin ginagamit yung congruence relation. But that was a nice point though. If you replace Z by R, you will still get an equivalence relation. Okay? Nice point. Any other questions? All right. So there's still a lot of examples here. But yeah. Susunod na dapat ay yung magandang property. Why are equivalence relations very important? Or ano yung consequences ng pagiging equivalence relation? Ang isang equivalence relation ay nag-induce ng isang partitioning ng isang set. And since we don't have any time left, I will ask your lab instructors on Monday to discuss with you guys how an equivalence relation induces a partition. Pero before that, dapat pala i-define muna nila kung ano yung isang partition. Okay? So that's what you're gonna do on Monday. So if you can, and yeah, if you are able, and if you have the means, please attend the lab sessions on Monday, because there I will ask our lab instructors to discuss how equivalence relation induces a partition. Okay? So yun yung gagawin nyo sa lab on Monday. Yeah, unfortunately, medyo running out of time na tayo and then holiday pa kasi sa Tuesday. So, yeah, sorry Esther, gusto ko maglaan ng lab hours for PS2. Mukhang hindi ko na kakayanin. So, I will ask your lab instructors probably for 1 hour talk about equivalence relations. But after that, yeah, you can spend the rest for doing the lab, for doing the problem set. Okay? So isang oras sa discussion, then 2 hours for the problem set. Okay, but the problem set will not be as long as the first problem set kasi kakaunti pa yung coverage. I already promised one of the problems, nabigay ko na siya last time for those who missed it. Siguro number one, I showed that the cardinality of the power set or the number of elements of the power set of a set of n elements is 2 to the power n. Okay? So using the principle of mathematical induction, so pwede nyo nang hanapan ng proof. Okay? Pero antayin nyo yung actual statement ng problem sa Monday. So meron akong ilalagay na caveat or PS dun sa instruction. So wait out for it. But you can start trying to prove it on your own. Or kung mahirapan man kayo, see a proof online and try to rephrase it or to paraphrase it into your own work bago nyo ipasa. And then probably siguro 2 or 3 more problems, okay? And this should be short ones, shorter than the previous problem set, okay? So I hope that's fine. And then since the 30th is a holiday, so we will not be meeting live, but I cannot afford to lose another meeting. So what I will ask you is kung face-to-face reading assignment na lang, pero the beauty of online classes is that you can join the class on Wednesday for my other for my other section, okay? So that's 5:30 to 6:30 on Wednesday. So you can join it live. Or if you cannot do it live, you can watch the recording. So the recording for that class, which is an assigned watching assignment for you. So magiging available siya around 7 p.m. So ipopost ko na lang siya sa Canvas. Or you can go to the MS Teams, hanapin nyo yung Math 101H Meeting 20. So doon din nyo siya makikita. Okay lang ba yun? Because sorry, I really can't afford to slack off or to miss one meeting. Okay? So that's it for today. So enjoy your long weekends. Hindi pala long weekend kasi meron kayong Monday. Tapos holiday tayo ng Tuesday. So enjoy the weekend and prepare for the second problem set. We'll see each other again virtually, hopefully in the other lab session, or if not, we'll see each other live on Thursday na ulit next week. All right. Bye, everyone. Oh, by the way, those who recited, kindly put your nickname in the comments. So, si Gad, I got you covered. Christian, put your name there. Sino pa ba? Yung mga nag-suggest din ng mga ideas or yung mga nagtanong, also that qualifies as a recitation. So paki-comment ng nickname, okay? Thank you guys. So with that, bye and see you on Wednesday or Thursday, okay? Bye guys.
Thank you, sir.
All right, you're welcome.